In today's video, we will learn about the variation in the properties of elements. So, we know that certain characteristic properties of atom or element like atomic size, valency, ionization potential, electron affinity, electronegativity, metallic character and non-metallic character, etc. are considerable importance when trying to understand many of the physical and chemical properties of that element, right? So these properties shows periodic variations. That means they gradually increases or decreases according to the flow in the periodic table, right? Within the group or in the period. A knowledge of these trends enable chemists to rationalize the observation and predict the chemical behavior of that element. Now talking about the first property, that is the valency. So what is valency? The valency of a valence element is shown its combining capacity with other atoms or elements. Nowadays, valency is defined as the number of electrons of an atom of the element that take part in the bond formation, right? In case of representative elements, like valency of an element is equals to the number of electrons in the outermost shell. For example, if we talk about the valency of nitrogen, right? So it has electronic configuration 2 and 5. So here 5 electrons are in the outermost shell, therefore the valency of nitrogen will be 5, right? Now for element of group 1 and 2, the valency of the element is equals to the group number, that is 1 and 2, right? And for the element of group 13 to 17, the common valency of the element is equals to the group number, like 10 or 18, right? So if we need to find the valency of the element in group 17, right? Suppose group 17 valency, so we just need to minus this group from 10, so we get the valency, that is 7. That means group 17 element has 7 valence electrons in their outermost shell. Now moving ahead, trends of valency in a group. So in a group, the valency of electron in the outermost shell remains the same. Therefore, all the elements of a particular group shows the same valency, right? For example, all the elements of group 1, that is alkali metals, have 1 electron, therefore its valency is 1. Now talking about the trend in period. So trend in period means what happens when we move left to right in a periodic table. So considering representative elements, as we move across a period from left to right, the common valency first increases from 1 to 4 and then decreases from 4 to 0, right? So here we can see groups, that is 1, 2, and then 13, 14, 15, 16, 17. Here first we see the valency, that is first 1, then 2, then 3, and then 4 in the 14th group, right? And then it gradually decreases to 3, 2 and 1 in the 17th group, because we know that in the 17th group the elements have 7 electrons in the outermost shell, therefore they need only 1 electron. That's why their valency is 1. So this is how the valency changes down a group and in left to right in a period. Moving ahead towards the atomic size. This is the second property. So the term atomic size normally refers to the radius of the atom. That means suppose this is the nucleus that is positively charged. So the distance of nucleus to the outermost shell is known as its atomic radius. Now for example, the radius of hydrogen atom is 53 picometers. Remember that 1 picometer is equals to 10 raised to power minus 12 meters and 1 angstrom is equals to 10 raised to power minus 10 meters. So here we see the atomic radius of hydrogen, that is 53 picometers. Now talking about the change in the atomic size along a period. So if we talk about the change in the atomic size along a period, that is from left to right, right? Now in general the atomic size decreases from left to right across a period. So here we can see, if we talk about a period here, like it is a third period, right? So the atomic radius throughout the period decreases from 186 in sodium to 99 picometers in chlorine. So here we can say that the atomic radius decreases along a period. Now talking about the decrease in the period atomic radius is because of the fact that the number of occupied electronic shells is same but the positive charge increases. That means the nuclear charge increases, that increases the attractive force on the outermost shell. That's why the atomic radius decreases, right, from moving left to right in a period. Now talking about what happens to the atomic radius in a group. So the atomic radius increases in moving down the group top to bottom. So if we move from top to bottom in a group, the atomic radius increases. For example, here we can see the group first element, that is lithium, sodium, potassium, rubidium and cesium. So here the shell number is also increasing, right? And also the atomic radius is increasing from 152 picometers to 262 picometers in cesium. So we know that now that in a group the atomic radius increases. Now as we move down in a group from top to bottom, the atomic number, that is the charge on the nucleus, progressively increases. Therefore, due to greater pull of the nucleus on electron, the atomic size should decrease. But also we know that on moving down a group, the number of occupied electron shells increases and therefore the atomic size should increase. But due to interweaving electronic shell which act as a screen, right, the outermost electron does not experience any full attractive force from the nucleus. Therefore, the effective nuclear charge is less than the actual charge and hence the atomic radius increases down the group. So here we can see the group 17 element in which the first member is fluorine and the last member is antimony. So here we also see the atomic radius increases down the group due to less effective nuclear charge. So I hope this topic is now clear to you. Thank you.